Hello Marvels, I am going to talk about geometric sequences and series right now because I feel like that is a topic that we didn't cover super well, so it'll be important to go over it again for the common assessment. This is number 7 from last year's common assessment, and I just want to talk this problem through with you. It says that the geometric sequence u sub 1, u sub 2, u sub 3 satisfies the condition that u sub 1 equals 27, that the infinite sum is equal to 81. So can we determine the first four terms of this infinite sequence? Given that, you may think to yourself, oh my goodness, what am I going to do? But I think there's a lot of common sense math that you can employ to help you narrow down the options. First of all, I know it's geometric. So since I know that it's geometric, if any of these sequences are not going down there's no common ratio, then I know I can rule it out. So from 27 to 18 to 12 to 8, it looks like I'm multiplying each one times 2/3. So this one that is geometric. From 27 to 18 to 9 to 0, this one looks like I'm subtracting 9 each time. Subtraction is not geometric, so it cannot be B. From 27 to -9 to 3 to -1, looks like I'm multiplying times -1/3, so that one is geometric. From 27 to 9 to 3 to 1, no longer negative, just +1/3, so that's okay. And 27, 18, -18, 12, -8, that looks like -2/3. Okay, so I'm dealing with 4 that were geometric and 1 that was not. Next, the infinite sum is equal to 81. So what that means is if I were to continue this pattern beyond the first 4 terms, all of them are going to add up to 81. Well, let's just pause for a second, because I know that if I add up what I have going on right here, some of them are going to seem like they're headed towards 81, and some of them are definitely not. So for instance, let me start with letter E. This is oscillating between positive and negative values, and so the outcome of the first 2 terms is +9. The outcome of the second 2 terms is 4. 9 plus 4 is only 13. The next term here is going to be a positive value, that's 2/3 of 8, and then after that it's going to be negative. Is this ever going to get as high as 81? No. If I add those terms, 13 is not on its way to getting closer to 81, considering these terms are going to get closer and closer to 0. So I'm going to rule out letter E. Notice so far I haven't even used a formula yet. 27 plus 9 plus 3 plus 1. Well, 1 plus 9 is 10, and 3 plus 27 is 40. So far this adds up to 50, but the term after 1 is going to be 1/3, because this is multiplying by 1/3, remember. The term after that is 1/9. The term after that is 1/27. Are these fractions added to 50 ever going to add up to 81? Again, my answer is no. If all of the positive values were not going to add up to 81, when I go to option C, which is positive and negative, these 2 values give me 18, these 2 values give me 2. So far I'm at 20, and I'm going to add 20 to positive and negative fractions as I continue to multiply times -1/3. That's never going to hit 81. So far I've ruled out B, C, D, and E, all because they couldn't possibly be the correct answer, which tells me that the correct answer must be A. Now, if I think that's my answer, I could always check it by saying the infinite sum of this sequence is going to be equal to A sub 1 times 1 over 1 minus the ratio. In this case, that would be 27 times 1 over 1 minus 2/3. To simplify that, that means 27 times 1 over 1/3, which is the same as 27 times 3, which is 81. That one checks out. I know that I'm correct. The correct answer is letter A. But I want you to recognize that I was able to get to that solution without doing this at all. This was only a check step to make sure that I was correct. So I am going to continue to use that method on other questions, and I think that you should as well as you work on your common assessment practice.